Hey, we're going to be talking about algebraic equations, probably one of the most important parts of that you can possibly even learn in college algebra, because what good is math if you can't actually derive up an equation and then do something with it? So it's extremely important. We're going to be talking about linear equations and modeling. And so we've got, let's see, we've got the sentence here. It says the sum of two consecutive natural numbers. So we want to write this out into some kind of equation. All right, so we're just setting it up. So the sum so the sum means we're going to add two numbers together, and they're consecutive. Like, for example, 50 and 51. Those are two consecutive natural numbers. If you don't know what a natural number is, let me just give you maybe some examples here of what a natural number looks like. 1's a natural number. 2's a natural number. All right, 100's a natural number. 0's not. Okay, and technically we'd write it like this. 0's an element of, but it's not an element of n. Alright, 0 is not an element of n. I got kind of crazy there with that. But -1 is not a natural number either. So all the negatives aren't natural numbers. So natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. But anyway, we don't know what the natural number actually is, so we're going to let it be an unknown quantity, and we'll just call it x. So that's our first natural number, and then the next natural number would be x plus 1. Because they are consecutive, right? X plus 1. Now we can shorten this by saying 2x plus 1. All right, let's look at another problem. All right, in this particular one here, we've got distance traveled. Distance traveled. Okay. The distance traveled in 2 hours by a car traveling at 65 miles per hour. So we're going to need to know the distance formula. So we've got a relationship between distance and time. Distance and time. So the distance is equal to rate times time. So our distance is equal to, and our rate is 65 miles per hour. So we're going to say 65 t. So that's all we'd have to do to set that up. All right, looking at this one here, this is an acid solution. We have the amount of acid in x gallons of 20% acid solution. So x gallons, so x is our unknown quantity, and we want to write the amount, right? Some kind of relationship of the total amount and the x gallons. So 20% of the acid solution. So how could we possibly do this? We could say the amount, which I'll just label as A, is equal to 20%, right? So 20%, or in this case, right, we're going to always write it in the decimal representation of x gallons. So that's pretty simple. 20% of the unknown quantity of gallons.